sum based on the theorems what we studied up till now. Here we have a very beautiful question which begins in the following way. Prove that the opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. So for this figure, we need to first create a circle. So let's have a circle, and this circle is circumscribed. We have a circle with center O, and this circle is circumscribed inside a quadrilateral. So we have a circle and the quadrilateral ABCD, and this quadrilateral ABCD is circumscribing the circle. That means all the four sides are touching the circle. That means all the four sides are tangents to the circle at points P, Q, R and S respectively for AB, BC, CD and AD. Now what are we supposed to do? We are here talking about the opposite sides of this quadrilateral, and this opposite side should subtend supplementary angles at the center. Now let's identify the opposite sides. There are two pair of opposite sides for a quadrilateral. In this case, the first pair is AD and BC, which we can see, and the second pair is AB and DC. Let's consider AB and DC. Okay, now when we talk about AB, AB has to subtend an angle at the center. The word subtend means make. Now which is the angle subtended by AB at the center? It has to be angle AOB. In the same way, CD will subtend an angle at the center, and which is that angle? It's angle DOC. But what should we do with these angles? We just identified them. Remember, we need to show they are supplementary. That means the sum should be equals to 180. The sum of the angles is 180. So we need to prove in the first case, angle AOB plus angle COD is equals to 180 degree. Okay, we have one more pair of opposite sides. This time we go for AD and BC. And AD and BC are subtending which angles at the center? Angle AOD and angle BOC. And we need to show they are also supplementary. That means angle AOD plus angle BOC should also be equals to 180. So the two proof is very clear. Let's start with the sum. Now we have four tangents, and we have the center and we have the point of contact. Whenever we have the center and the point of contact, we can always draw the radius. So we'll draw four radii, OP, OQ, OR and OS as the construction over here. This is very clear. Now we know the radius is always perpendicular to the tangent. Hence, the radius will be always intersecting the tangents at a right angle. So what? We have something special. Look at these two triangles, triangle APO and triangle ASO. In these two triangles, that is triangle APO and triangle ASO, we know angle APO and angle ASO are 90, radius is perpendicular to the tangent. That means they are right angle triangles. The hypotenuse AO is a common side, and it's one pair of corresponding sides, that is OP and OS are the radii, so they are equal. That means the two triangles will be congruent by the RHS rule, right? So the triangles are congruent. So what happens if the triangles are congruent? In this case, we now say angle AOP will be equal to angle AOS. The reason is CPCT. What we'll do for our convenience, let us assume the value of these equal angles to be A degree, result number 1. Similarly, we can also work for the remaining pair of triangles, and we can now get the following things. Angle BOP is equals to angle BOQ, whose value will be taken as B degree. In the same way, angle COQ and angle COR will be C degree, and angle DOR and angle DOS will be D degree. We name it as result number 2, 3 and 4 respectively. Now what? As I said, for every variables what we introduce, there has to be certain relation. Over here, we have a point O around which we can see many angles having values A, B, C and D respectively. But sum of all the angles at a point is 360. But here we'll specifically talk about four angles, that is angle AOB, angle BOC, angle COD and angle AOD. And we know sum of all these four angles is 360. Sum of all angles at a point is 360. Angle AOB, the value of angle AOB is A plus B. In the same way, the value of angle BOC is B plus C. The value of angle COD is C plus D, and the value of angle AOD is A plus D. And the sum is definitely equals to 360. Hence, we now have 2A plus 2B plus 2C plus 2D is 360, which means twice of A plus B plus C plus D is 360, which gives us A plus B plus C plus D to be 180, definitely. But we have an equation where we have A plus B plus C plus D 180, and definitely we require 180 in the question also. But in the question, we require sum of two angles to be 180. If you observe A plus B very carefully, A plus B is the value of some angle. It's the value of angle AOB. So A plus B is nothing but angle AOB, plus C plus D is the value of angle COD. Hence, we now have angle AOB plus angle COD is equals to 180. And apparently, this is what we need in the first part. What about the second part? Equation number 5, which we have created, can be also written as A plus D plus B plus C. That's equals to 180. So, A plus D plus B plus C is 180. That means what? A plus D is the value of angle AOD, plus B plus C is the value of angle BOC. Hence, we now have angle AOD plus angle BOC is 180. And you know what, children? That's what we need for this question.